All right. Hello, everyone. We're here today with IRD balancing, but we're under our Lexeco branch today on our core loss testers. Might reference it as a CLT, but we're going to be doing troubleshooting and going over if you're having issues with your core loss tester, you might need help in diagnosing what's wrong. Maybe we need rebuild. Maybe it's just a simple component replace. But either way, it'll get you a better idea what's going on without having to incur shipping costs and all the other costs of consultation. So the two things we're going to focus on is if the fuses are blowing, L1 and L2. They're blowing consistency. They're blowing about every month, every 2 months. They should be lasting longer than that. So we'll go over the issues that are associated with that. Generally considered it's a voltage drop or aging components. The unit we'll be going over is a new build. Some of you all will have upgrades. It'll be a little bit different. And we just want to be careful and watch out what we're doing there. The other thing we'll be going over is maybe the meter's not turning on. You hit the on button, the contactor doesn't engage, or the CLT, you're not able to ramp it up, you're not able to ramp it down. Once it does, in fact, come on, you're not getting any actuation from the unit. So we'll be going over how to troubleshoot that and to get your basic test controls troubleshooted, where we could easily send you replacement parts once you've got it diagnosed. Otherwise, our company and facility is more than welcome to take the service. This is going to be testing on a live unit. It will need to be energized in order to take these readings. So whoever's doing it, make sure you are prepared and qualified to do it. Just be conscious of your hands and your arms as you go in and take readings. There are live components, and so there is a safety hazard involved, but it is just required to take these readings for troubleshooting. Now, maybe you're having trouble ramping up and ramping down. So we're now going to go dealing with that. We're going to go back to where we were before on volts DC on the meter. So volts DC. I'm going to go ahead and turn the meter on, and I'm going to ramp it up as much as I can with our armature that we have attached. Okay. All right, now that actually isn't max ramp, but it's just ramped up. It is ramped up and going. So what I'm going to do is there is another set of black and white wires right here that you can see. They look the exact same as the ones up top, and they're going to the SSR here. You could also measure it here as well. Doesn't really matter where you do it, but I'm going to go ahead and select it for now. Black is negative, and white is positive. Same situation. All right, so if you can see that, it's reading 0.57. So as you hold the up arrow, that's just going to slowly increase voltage. Omar, if you would, please go ahead and hold the up arrow as I reconnect that. All right, you're good. If you hold the up arrow. All right, if y'all can see that, that's just slowly going up. All right, that'll be fine. Will you hold the down arrow now? All right, thank you. So that's basically that meter up working. So we know the up and down arrow. If you're getting that volts DC change, now I will mention polarity matters, so it needs to be a positive. If it's negative, it won't work. So we know that the meter is good at this point. What we're going to do is we're going to go ahead and lift the lid. There are 4 screws. We've already removed them. Your unit will also have a front panel. We've removed it for our access, and we removed the breaker side panel already just for this video. For older units that are more upgrades, that's going to be a box top and everything's going to be sunk in. It's going to be much more difficult, and it's also going to be a little more hazardous because you're having to reach in to reach everything. Once again, just be conscientious, be safe, wear all your proper protection gear, all your PPE that's required by you and your facility, as well as I always recommend if you're not familiar with the unit, have a second person help you, and that way it can make things a lot easier on you, and you're not having to distract yourself and possibly could touch something. So what we're going to do is we're going to lift up. For you guys as customers, you can do whatever you want. You own the unit, but for us, we protect it. We don't want to raise this while the lid's open because it will scratch the back on the new unit. So we use a block that gives us access to this meter still, so we can use the controls with still having the unit up. All right, we're going to bring this closer. All right, hopefully I didn't disorient you too much. All right, so what we're going to do is you're going to need a multimeter, preferably one with a min-max feature so you can take instantaneous readings, and it can possibly pick up the inrush current, both current and voltage drop if that's occurring for you. For what we're doing right now, we're going to start on the meter not turning on, contactor not turning on, and the unit not ramping up and down. So we're just going to go over the basic controls. The first thing you should do before you do any of this, for either this one or the next setup, check your incoming voltage, make sure it's correct, and I'm going to go ahead and show you. You should check these two transformers down below. So those two black transformers, your incoming voltage should be whatever your unit is set up as at your facility, but the output needs to be 120. 120 volts AC, doesn't matter what's going in, 120 volts AC should be coming out. If it's deviating too far, more than your 10% variance, then you've got an issue and you need to resolve that first before you move forward with anything. So in this case, we're going to go ahead and turn this on, and I'm not going to be able to show you that meter. I'm just going to have to tell you what's going on, and we'll go off of that. So unit is now energized. We're operating our unit at 460 volts incoming. I have my multimeter here, and the first thing we're going to do is go to volts. We can see that? Good. Okay, volts. And I'm going to switch on over to volts DC. All right, so right now my meter is on. My impedance breaker is turned on. That impedance breaker, if it's ever tripped, it's heat related, so it just needs to be cooled off and it'll work. But the meter is off. I'm going to hit the on button. You will not be able to hear the contactor engage due to my headset, but I'll just be vocally telling you. So contactor is on, unit's engaged, you get a little hum. So now, to check to make sure that contactor, for you, if your contactor didn't come on, the first thing you're going to do on a new unit is these two wires up here. There is a white and a black. It's 490 and 450. Those are the wire numbers. Now, polarity matters, and this is volts DC I'm checking. So the black is negative, and the white is positive. So with that, you should be able to see, flare's a little bad, but all right, 3.4 volts DC. That's enough to fully turn on the SSR. So that tells me the meter is working. Your on button on your meter is working because it's putting out the 3.5 volts DC. Now, we may not know if 120 is going, so we're going to check that. I'm going to switch over to right here on this panel is a neutral. That's a neutral for the big transformer, and that's the power we're using. And then this is a 180 wire junction. Thank you. Yes, you will need to switch your meter back over to AC. So, DC is not going to read anything. All right, 117 volts. That's pretty good. Now, I'm going to read the output, and it should be 120 as well. All right, 116, a little less, but that's perfectly fine. That meter is on. I'm going to turn it off. All right, contactor just shut off. So this is the 180. Should be on all the time. It's a normal 120 volts. And then coming over here to this one, it's 0. So that SSR, sorry, that SSR is in fact blocking the voltage. So we know the meter is working. We now know that the SSR is working. So the SSR, when it gets 3.5 volts TC, it is turning on. If you are super confident, you can always supplement that 3.5 volts with a separate power supply, and you can turn on that SSR manually. I don't recommend it, but it's an option. So at that point, your contactor should be coming on. If not, then you might need to look at your actual contactor. So your actual contactor down here, um, you want to check and make sure you got your 120 volts coming out onto the on power and it's just not a connection problem, or that contactor may need to be replaced. We do put a resistor because new contactors don't have much of a load and it's causing dropout. So that may be a thing too you want to look into. All right, so at this point, we have checked and we know that's going to be your contactor. That's how you're able to check your controls. It's just as simple as a 3.5 volts DC and a 120 volt AC. And at that point, you've troubleshooted the circuit that's controlling your contactor. Now, you can also check here on the SSR. You can look on the reading, take a picture, use your phone, zoom in. There is a positive on the part that needs to be positive, so you can check your polarity there. Um, if your unit's working, then if your unit's been working in the past, then you don't have a polarity issue or it wouldn't have worked, but you can watch out for that. Now, we want to switch to volts AC again. Okay, and we're going to have, just like the other SR, we're going to have an always 120 on, and then we're going to have another output that sort of varies on this unit. The previous one was on or off, no in the middle. This one's going to slowly ramp. So put this on neutral, and if I hit the always on, I should be at 117 because that's what we're getting off of our power. And then when I go to the other unit, I got 16 volts AC. So that's just going to change with as much as I hold that up arrow. It'll go all the way up to 120. You might max out before that, but it'll be your 2,000 amps through your cable. That's going to vary. That's going to linearly change with that increasing voltage. So that SSR is working. You can go ahead and max it out now. So I'm just ramping the unit up to the max it'll do. On this armature, we may not hit full max, but um, it should be pretty close. So there. Where are we on that? 85. Okay, 85. Not quite there, but close enough. Also, what you can do is on this right here, this DC transformer, you can check that white and red, and that's going to be that same 85 volts that's coming out going into it. So as that ramps up, that's where that should be going. You can check on that end to make sure you don't have any connection issues or anything further than that. Okay, sorry about that. All right, so we've checked that. So at this point, we know that SSR is good because it's allowing it up. You should go ahead and max it out to make sure you get that full 120. If you don't, that DC supply that I was pointing to does have a low and high feature. You can change that tap to account for if maybe instead of 120, you're only getting 110. Or maybe instead of 120, you're getting 130. You can account for that incoming voltage, and that'll be based off the power from your facility because it's not going to be the same day to day. So your 460 may be coming in at 420, maybe coming in at 480. Um, if it's beyond the 10-15% tolerance, then you may need to look into fixing that. But the unit is not, it will work, but you do need those tolerances to make sure everything works to the best of its ability. And it will certainly help if you're running into issues, especially with fuse blowing, to have everything properly aligned. All right, hello everyone. This is going to be familiar for those of you rocking older CLTs. So we have obviously changed designs to a circuit board situation, but for your older units, this is going to be your layout. If it doesn't look like this, then you are on the very old units and you're sort of on your own there. But for these models, Where you are, it's going to be the exact same thing. It's just going to be a different layout. So I'm going to go over that very briefly. Um, when we talked about the 0 to 3 volts, raising it up, it's the same thing. Black is still negative, white is positive. Oops, there you go. So right here, these two wires, I know it's cut off, but that is what you are, is right here and here. You're checking for the 0 to 3 volts. That should be turning this unit on to where 180 is always on live if you're checking to the neutral. And then the wire down here is going to be the 120 going out once you hit the on button on the meter. So once you're doing that in the neutral, you should be seeing 120 out, and that's engaging your contactor. If you don't have the 3 volts here, it's the meter. If you don't have the 180 here, it's your transformers. If you don't have the 180 coming out, once you've hit the on button, then it's this black SSR. And on this old assembly, we don't replace it. You're just going to have to get an upgrade. On the ramping up, ramping down circuit, same thing, 0 to 3 volts DC. You're looking to see as it scales, as you hold that up arrow, it's going to linearly increase. You can check it as here as well. You're making sure you don't have a bad solder connection or anything going on. Same thing for here, your big wires. The 250 should always have the neutral in, and it's going to be 120 all the time. And then as this ramps up, you should be getting 0 to 120 volts AC out going to that transformer I showed previously. So if you don't have 0 and 3 volts, polarity matters. Increasing, it's going to be the meter that failed. If you do have that increasing, if you don't have 120 volts all the time continuous, then that's going to be your transformer that's going bad. And if you don't have 0 to 120 volts AC coming out, scaling, then that is going to be the SSR. If you do and you're still having problems, then that could end up being also the rectifier diodes. But at that point, at least you know the rest of this circuit, which is our normal replacements, are at least either good or bad, and you've pretty much diagnosed 80% of the machine at that point. So that's really it for the old style. Just wanted a quick overview to where it's not quite the same as our latest production models. So, all right, hello everyone. We're back over here at the breaker panel. We're going to be focusing on maybe you're blowing fuses FE1 and 2 for line 1 and 2. They're blowing frequently. Maybe they're blowing once every month, every 2 months, a little more frequent than what it should be. So we're going to go over the main culprit's going to be voltage drop. Sometimes transformers can age out or components can go bad, but most of the time that we've experienced this, especially with a new customer, a new setup, a different facility, maybe a different part of the facility, it's going to be your power panel is not enough to handle the inrush current that these machines pull. So for a split second, when you turn them on, they pull the max amps and it probably even exceeds it for a split second. So that is the inrush current. You need time delay and you need your fuses and breakers to be set up to handle inrush current. Not all breakers will be designed to, they'll trip immediately the moment the amp is exceeded, and so you need the specific equipment to handle inrush. So this unit here is a 460 volt. We're at 462. We're right at that nominal voltage. Maybe you'd be running 440, maybe you're running 480. Just depends. There are some settings you can change to adjust that, to accommodate it, but we are nominal, so we are good. I'm going to go ahead and turn it on. Now, what I would normally do in this situation is, this is actually live. I would hook up your alligator leaves, obviously, when it's dead. And that way you don't have to get your hands in there. It's a little more safer. Yeah, this is a way a single person can do it, although I do recommend having 2 people if you've not got experience troubleshooting this. So what we're going to do is go ahead and I have it there, and I'm going to change this. Once again, I said it'd be very helpful to have a min-max function. So I'm going to actually change it to min. And that way it's going to read the smallest voltage. So as I turn this unit on, we're going to see my meter's not changed. Sorry, my meter's not changed at all. I'm going to turn it off. I'm going to turn it on. Now, If you're blowing fuses, I hate to tell you, that's just 3 fuses you probably blew. But at least you're able to see a min-max, and you're going to be able to see a voltage drop. You're going to be able to see that voltage drop to 420, 430. It shouldn't drop. It shouldn't drop at all. If you're seeing droppage, then your facility does not have enough power. You don't have a dedicated line. There really could be multiple reasons, but the problem is actually at your facility. This unit is designed to operate with as much power as it needs to operate, and if you don't have it, you're going to be getting into voltage drops. Uh, so that's where you check the incoming. You do that as many times as you need to before you can validate there is or there is not a voltage drop. I'll also show you how to be checking that on the currents up front. So I'm going to go ahead and turn the unit off for right now and disconnect my leads, and then we're going to transition over to the front of the unit. All right, we're back, and we're going to be looking at the front of the unit, checking some of the transformers, DC supply, fuses, going over that, contactor. So the first things first, we're just going to go over the basic connections of the transformer and the voltages you should be seeing, and then we'll go on to some of the other components. So we'll start with this. So let me get down. So first things first, these units all have incoming voltage. Their difference, it's going to vary for yours. This one is 460. No matter what it is, it doesn't really matter. Just make sure it is what it should be for your facility. You'll need to look at the stickers on the transformers, read the IRD schematics supplied. If you don't know how to read those or don't understand them, do some self-study, or unfortunately call someone else in who does know how to read those. But we're going to check and make sure that the voltage is set up and properly wired for its incoming voltage. This one's 460. Now, you don't need to know any understanding, but you can at least take the initial reading. So volts AC, I don't need min-max anymore, so I'm going to clear that off. And we're going to take a reading of the incoming. This unit is on and operational. So I got 460. I'm going to read the bigger transformer. It should also be reading the same. 460. All right. If you have anything other than 460 or the nominal voltage you should be getting, then you have a problem and you need to rectify that first before you move on. The output, doesn't matter what's going in, output needs to be 120. It is AC, so you don't need to change anything on your meter. So that is 120. That is 120. Going over to this side. This one is 120. So that one is doing really well. It's reading good. Now this is a new unit. We took the panel off. It's easy access. It's very safe to do these readings. If you have an upgrade or an older unit, unfortunately these transformers are probably going to be mounted on the side and you're going to have to reach in. I recommend using your phone, modern camera, whatever, to get in there, take some video, take some photos. So that way you can read the information and already know where you need to touch and what you need to do. While the unit's off, you take this video, and that way you can look at it with your head out of the unit and not having to be upside down while you're trying to figure out where to touch. It is a lot more dangerous on the older units, so just be careful, get an extra hand, get whatever you need to do it safely. If you aren't comfortable with doing it, send it to us. That's the way it works. Send it to us. We'll troubleshoot it for you. We'll get you up and running, or we'll be telling you, unfortunately, the unit's reached the end of the life and it's time for an upgrade or replacement. So we got the 460 going in. We got the 120 out. We checked the wiring, the schematics. I'm not going over that. That needs to be your own understanding. But you read it and you make sure it's right, it's there. And then you're checking out for 120 going out. You can also check at the fuse blocks. Maybe you're not able to get to the meters, but you can still check using the schematic, trace the wiring, and check at the fuse blocks ends. For those who are dealing with fuses, the fuse blowings, 1 and 2, you might need a pack of 20, I'm afraid. You might be going through a lot of these because you'll be only be able to take these readings for a split second. And that's where using the min-max function of the meter can be really helpful. You just have 1 single second to get the min number to see if that voltage drop. Um, and that's all you can do, and you'll just have to replace the fuse, go on. Theoretically, you could buy circuit breakers for DIN rails if you want to fuse it appropriately. That is not supported by us. That's entirely up to you guys. That's an option, though. Um, let's see. Once that is done, we're going to go ahead and switch over and talk about amps. Okay, so for me, I don't need these anymore. We're going to switch over the unit to amps. Okay, and so I'll have a clamp meter. Makes it easy. You have your own. You might have a fancier. It doesn't really matter. It just needs to work. We're going to take a reading on the no. This is a no power. The meter is not yet on, but everything is live. So we're going to take a reading. I may have to talk you through if you cannot see. Yeah, there's some, but basically this is reading 0.06. So I have almost no draw on that small transformer. This 0.5 transformer, 5 kVA, doesn't matter where it is. It's going to be the 500 VA transformer is just powering the meter and the laptops. That's all it is. That's all it's powering. So there's really never going to be any draw. If you do have any significant draw, then obviously something has gone wrong, and you need to go downstream and figure out uh, what's increasing that current draw to be more than like zero point 0.1 nominal. Okay, now the bigger transformer on this one, it's a 1.5, could be a 3, could be a 2. Doesn't matter. It's bigger than a 500 VA transformer. So it's going to be the big one. That's the one that's actually powering your DC supply, which does the controls of the VRT and allows it to pull main power from the wall. So this is going to be the one that if you're tripping, it's probably going to be this transformer because it's the one that actually has a load on it. So at no at no load, we're at 0.2 amps. 0.2 amps without anything on, so that's what we're drawing. I think these fuses for this unit's a 2 amp fuse, so obviously we're way in the clear for that. No issues there. We're going to check the outgoing as well because it'll have a little higher fusing, 0.05, so it's got even less of a draw because there's nothing on pulling it. I'll check this one too. This one should be about, yeah, 0.06. Once again, there's just no draw going on. We don't have laptop printers hooked up for this rental unit, but even if you did, they would be nominal at best. So what I'm going to go ahead and do is I'm going to leave this hooked on. I'm going to set it to amps, and I'm actually going to switch it to the max component. And then you should be able to see that, and I'm going to ramp the unit up as far as this armature will let me. And then once that's there, you'll see this slowly go up, and then I'm going to start cycling power because once again, I'm looking for voltage drops and inrush current spikes, which is going to be the #1 cause of the fuse blowing. If none of these values work out, then obviously there's a issue later on, but generally the #1 cause is voltage drops and rush current spikes. And so we're just going to go over that real fast. All right, contactor is on, unit is humming. I am slowly ramping the unit up. All right, so I am currently at max what the armature will allow. That's not max of the unit. It may not be max for your unit, but I'm as far as it's going to allow with our current setup there. So if we look now, it is at 0.93, 0.95, basically 1 amp. 1 amp is what I'm pulling, and it's going to stay that way. That's the max of what I should be getting with my current setup. So now that I know what the max is on a normal ramp up, and in case you're blowing fuses, you may not know this, but you can at least check that your fuse and that number, that number is less than the fuse. What I'm going to do now is I'm going to go over to the breaker and I'm just going to turn it on and off a couple times. And we're going to see if I can't get a higher inrush current going on through the initial turn on of the unit. Once again, if you're blowing fuses, this is going to cost you a fuse probably every time you do this. Buy a box of 10, buy a box of 20. Um, if you're a professional, consider subbing in a breaker so you're not having to burn through fuses. All right, so that is on for the first time. That already jumped up. Don't even have to do it a lot. I recommend, hey, 10, 20, as much as you can, much as fuses as you got. That already jumped up to 1.36 amps on that meter. I don't know if you can see it, but it's there. I should be able to actually pull it off. Oh, that actually got more. That was just because it messed up when I unclamped it. But that was 1.36, so that already had inrush current being applied. That min-max feature, that max, recorded it for that split second that it was on, and that was how I was able to tell. Yeah, okay, 3.20. Yeah, so we're really getting some inrush there. And sometimes you do need to do some readjustment. All right, 6.3. 1.3, 2.65. All right, yeah. So I think for a 2 amp fuse, we did exceed it there, and that's going to be the inrush. That should be a time delay, should last very well. You should have no issues with that. But if you're jumping up to 4 or 5 volts, then that's going to be where your inrush problem comes from. To where you can also do this the same way. Hook it up to voltage, use alligator clips to hook onto that transformer, and you do your min-max function on the voltage, and you're just trying to make sure that your voltage is not dropping below that 460 or whatever your nominal is. If you are, then obviously you're not supplying enough power, and doing that inrush heavy draw, you're getting way too much current to trip that breaker. Now, obviously, we exceeded that fuse, but it's a time delay, so it doesn't matter. I can still turn it on. Unit will work. You can't hear the hum, but it's definitely still working. We have no issues at this moment. The unit's designed to handle that, but if you're in a voltage drop, insufficient power draw at your facility, then obviously it's going to blow that fuse. It could be if the got an old unit, that transformer's 10 years, it's just not as efficient. So getting a new transformer can help. You'll get a little bit less of a loss there, and it'll lower that amp rating, so that can help, but that's going to be on a old unit. New units shouldn't be dealing with that problem. The other thing you can check is back on the amp, checking amperage on units and everything. Um, we want to go ahead and let it back to amp and max. I might need to move the camera. So I can check right here on the volts. Uh, volts. DC power supply. Okay, so right now the unit's off, and the unit will stay off because I'm not turning the meter on. So I'm not getting any readings. That light on. I'm not getting any readings because there's no draw. If I was getting anything, then the diodes may be bad, or the 50 amp SSR may be faulty, and it's no longer blocking voltage. And that's why you're blowing fuses, is because it's letting voltage through, and the unit's not basically starting at a 0 point. It's starting with an actual load. So if I turn the unit on, the unit is on now, and now I'm going to ramp up. We are going to begin to see a little bit higher usage there, of where we just see that's linearly raising with the increase of output. So once again, that shouldn't exceed uh, anything on the output side. It may not be the same as your input because there is a transforming conversion there, but you should not be exceeding anything on the output. If you are, then you'll need to deal with that math and figure out what's going on. Could be the diodes, um, could be something else, but most likely it's going to be the diodes on that transformer because it's just a basic transformer, and then those diodes are rectifying. So that's pretty much it at this point. There wasn't a whole lot to the circuits, so we've sort of gone over the voltage drop and the power. Once again, when you're testing these units, just be careful not to touch anything. Our new units, new design is much better to allow you for safely troubleshoot versus any of your older designs where you're having to reach down into the unit. Just do your best to not touch anything that's possibly live at all. Um, but yeah, I think that's everything we got. Hope this really helps. Hope this can save a visit for us and your unit keeps working. Otherwise, we'll be glad to take the service and we'll um, get you up and running no matter what it takes. Have a good day.